In this video, we'll be talking about automation and machine learning. These are two technologies that predate large language models like ChatGPT, Copilot, and Gemini, but these technologies are still extremely important and extremely helpful. Automation is the ability to essentially record a set of actions and play them back later. Imagine pushing a button, maybe pushing a few buttons after that, and then ultimately being able to record that and play it back automatically so that you don't have to push as many buttons in the future. Machine learning is the ability to train a computer to recognize patterns in data. This could be something like facial recognition, translation, health insights, personalization, content safety, or many other things like temperature anomaly detection, speech service, and many other technologies. Machine learning can cover a vast amount of topics, so we will be showing you how these technologies essentially can be used, and also we'll point out how they can be combined with this newer technology that we've been talking about, being large language models like ChatGPT. Let's get started. Let's talk about automation. Power Automate is a tool from Microsoft that has been around before ChatGPT. This tool is the traditional process we call robotic process automation. And basically that means that we can take steps that we do every day and automate them to make our lives a little bit easier. Let's take a look at how we can access Power Automate and exactly how we would use it in our day-to-day. So I'm here on office.com. I'll go ahead and open the app launcher here in the top left, and you should see Power Automate listed here. If you don't, it may be in the More Apps section if it is available to you. So we'll go ahead and open Power Automate. And welcome to Power Automate. Now, there is a ton to learn here, but it's also really relatively simple to use. So let's start by taking a look at our templates here on the left-hand side. And let's just read through some of the templates to give you an example of what you might use Power Automate for in your day-to-day. And we'll start with maybe some top picks. Perfect. So for our first one here, we have an instant workflow, which does follow up on a message. So you'll notice that each one of these is what we call a flow or a workflow. And what that means is it takes a trigger like this message here in Microsoft Teams and follows a series of actions after that to automate a particular task. So for this one, we're taking a message in Microsoft Teams and we're creating an automatic reminder to follow up in it. Pretty simple, but again, that can be something that's pretty effective. Let's take a look at another one. Maybe let's do a classify and route emails using GPT. This is pretty cool. Let's take a click. So it says that it will classify and route emails with a specific subject to the appropriate team using GPT. So traditionally, you may create a ton of email filters in your Outlook inbox, and this can be effective, but again, it may take 30 minutes, an hour, or even many weeks to set up properly because you have to identify each type of subject, each type of sender, each type of email address that you're trying to filter into a particular folder. But now we can actually combine the power of automation with the power of a GPT model to actually point our emails in the right direction intelligently based on their subject matter rather than the particular words and keywords that we've already highlighted before we receive the email. So this is a fantastic addition to our emails, but let's take a look at some more templates here. Let's see what we have next. So this looks pretty good. Notify me and store the responses when a student completes a quiz. So this takes, let's go ahead and click on it, Microsoft Forms. So we have a form that our students are completing, and we would receive an email notification when a student completes the quiz on Microsoft Forms. And from there, we would also store the form response in a SharePoint list. So we're taking in our students' data as a form, nice and pretty, very user accessible. And we're taking that file or that quiz result and sending it through an email notification to say, hey, this person, this student just finished this quiz. rather than giving all of that data here in the email, we're actually storing that data safely and securely on a SharePoint folder or a server, allowing us to, again, separate our data, but also keep it safe in the cloud. This is something that, again, we could have done on our own, but why would we want to manually do this when we can have an automated flow do this for us every single day, every single time someone submits a response to our quiz? Let's take one more look at our templates here. And I think this one looks pretty good as well. Again, just another great example of a trigger and a result. So email yourself new tweets about a certain keyword. So let's say we wanted to get an email anytime someone talks about our school, or maybe we have a particular hashtag set up that we'd like to track. Well, we can actually set this to email us anytime someone talks about that hashtag on social media. Again, pretty simple. It's just a 1-2 step, but that can be something that can really help you track and keep up to date on a particular subject. There are many different templates. These are created by Microsoft as well as the Microsoft Power Automate community. So really anyone can publish their own workflow here. And that's why this can be really, really helpful, because there are specific flows for things like remote work, approval processes. If you need to maybe run things by a few people to get it approved before you actually complete that action, these approval flows are really great for that. As an example, this one says request approval. Everyone must approve for a selected item. Again, we have a SharePoint list. It's sending an approval. It's sending emails to everyone, and we're waiting until everyone completes that to actually approve that particular task. So these are some of the examples of flows that you can create. Let's go to the create section, and we'll break this down a little bit further. So when you create a flow, there are 3 ways to get started. There's the automated cloud flow, which is triggered by a designated event. So again, this could be something like someone talking about your school on social media, or maybe it's a particular message being received or an email arriving in your inbox. Whatever the case is, we can set an if type of statement to say, if this email arrives, then do the rest of these things. Next up, we have instant cloud flows. I like to say that these are at the push of a button because it's triggered manually as needed. So that means that anytime we push this button, the rest of the steps in our flow will occur, but only after we push that button. Next up, we have scheduled cloud flows. You choose when and how often it runs. So this means that you can schedule this for maybe once a month or once a week or even once every minute. But whatever the case is, you can set your scheduled cloud flow to run on a particular date or particular time. And just like the rest of our flows, it will follow the rest of the steps in the flow once that particular date or time has been achieved. This is a relatively new but fantastic feature. Describe it to design it. So using natural language, we can talk to an AI model like Copilot, and it will actually create new Microsoft Power Automate flows for us. Ideally, you would say something like, I would like it so that anytime I receive an email about accounting, it automatically goes to the OneDrive folder labeled accounting, and it also sends me a message letting me know just a quick summary of what that email was, maybe, right? Again, maybe you have no idea how to create that, and that's okay, because by describing it here, we can use large language models to help us actually design our flow and get closer and closer to what we're trying to achieve. Next up, we have desktop flows. And so this automates processes on your desktop environment. A great example would be if you have an app, let's say an accounting software from 1994, and every time you go to file an invoice, you are required to use this software from 1994. It's not really, the most prettiest process, but it gets the job done. Well, you can actually record yourself using this software, and every button click, every drop-down menu that you go through can be recorded, and in the future, we can automate the process of filing these invoices using this desktop flow. Last but not least, we have process mining, and this is once you already have a few different processes and flows set up, we can actually evaluate and optimize those existing processes and tasks using process mining. The next way to make a flow is starting from a template. So we've already talked about our templates, but again, It's a great way to get started. I would highly recommend starting with a template first because it gives you an idea of how these things work and exactly how you can do it on your own. Last but not least, start from a connector. So this means that if you know where your data is coming from, you can actually start with that as your starting point and work through that to create something that is useful to you. Completely custom, but again, you just know where your data is coming from, and your data can come from just about anywhere. Whether that be your email, SharePoint, the Microsoft Dataverse, OneDrive, Forms, Planner, Outlook, RSS, a SQL Server, Power BI. There's all sorts of ways that you can pull in data here to Power Automate. But again, in combination with our newer tools like large language models, this type of automation can be really, really powerful because essentially it keeps things on the rails. It makes it so that only those things can happen when a particular set of conditions are met. And that can be a real cost saver, a real time saver. So definitely that's why I'm including automation here, because it's still extremely relevant and most people will forget about tools like this as they move towards tools like ChatGPT or Copilot or Gemini or whatever large language model you're using. Please don't forget about this type of technology, which is automation. All right, so let's talk about the different types of machine learning models that you can actually create on your own. And these machine learning models would be capable of running on a mobile device like an iPhone or an Android. Now, there's many different categories and subcategories of machine learning. So let's start with the left side here and we'll break this down by category. So we'll start with images, and image classification is pretty straightforward. It classifies the dominant object or scene in an image. So to create something like this, we would maybe take, let's say, 100 pictures of a tree and 100 pictures of a mountain and maybe 100 pictures of the ground. And ideally, this model would be able to identify anytime we see a tree, or maybe we'll add in something there, let's say a flower. So now we're looking at trees, flowers, mountains, and the ground. And what we've created, if we take 100 images of each one of these, we can actually train a machine learning model that can distinguish between specifically a tree, a flower, the ground, and a mountain. And that means that every time our camera points or we send it a picture of a flower, it should correctly identify that we have a flower as the dominant object in the scene. Now, if we were zoomed out too far and there's a mountain in the background, then maybe the mountain would be the thing that takes over the image classification. But at its heart, that's what image classification is. It's pointing out the single most important thing in that image. The cousin or sibling of that would be multi-label image classification. So this would be the ability to take that zoomed out picture and highlight each one of the topics or subjects that we've highlighted in our machine learning model that could be a focus. So that same image where we zoomed out and it identified the mountain, now we could use that exact same image and identify all of the elements. We could say, oh, there in that background is a mountain, and here in the foreground is a flower. Somewhere in the middle, there's a tree, and also there's a ground there as well. So multi-label image classification can classify multiple objects or scenes in an image. Next, we have object detection. And so this is going to allow you to locate and classify different types of objects in an image. Now, again, this may sound pretty similar to what we just talked about, but the main difference here is that this is going to be focused on an object that is a little bit easier, or let's say, how would I describe this? Let's say harder to distinguish. So something that is, let's say, like a rubber duck, we can actually classify this from multiple angles if we were to use something like object detection. And that way, if only a piece of the rubber duck is in the image, we can still identify it as a rubber duck, whereas the image classification model may rely on seeing the entire duck. Style transfer allows us to transform an image or video to adopt the visual style of a reference image. So if we have a painting like a Van Gogh or a Starry Night or some other particular artistic style that we would like to emulate, well, we can use style transfer to make a picture look like another picture. You've already seen this if you've ever used a social media filter. That's essentially what they're doing is we're taking an image and we're applying a filter to it to make it look like some other type of image, whether that be an image that was taken on a particular camera or a painting rather than a photograph. Last but not least, we have hand pose classification. This one is for identifying which hand pose is currently being used in the image or video. So that could be a peace sign, a thumbs up, the Star Trek sign here, or whatever hand signal you'd like to use. We can actually train our own custom AI models to identify hand poses and that way trigger other actions within our app. So you may have seen this if you've ever used something like Teams or Zoom and you put a thumbs up in the camera and suddenly there were confetti and fireworks shooting out of your thumbs up. That's what they're doing there. They're using hand pose classification to identify that moment you give someone a thumbs up and then acting on that by emitting those particles like the confetti. Moving on to video, again, we've already talked about style transfer, so let's talk about action classification. This is going to be the ability to classify a person's action in a video clip based on their body movement. So imagine creating an ML model or a machine learning model that can identify when you're running, or it can identify when you're doing push-ups, or it can identify when you are doing cartwheels. Whatever the case, that is an action that we would have a video of. And again, by providing multiple videos of that action happening, we can correctly identify when anyone is cartwheeling, running, whatever they're doing. It's definitely going to be much easier and much more effective than using a traditional AI model like ChatGPT, because that model relies on not as continuous of a video feed. So this would actually be real time, whereas something like ChatGPT is actually only taking an image maybe every 3 or 4 seconds. Hand action classification allows us to classify a hand gesture in a video clip based on the fingers and hand movement. So again, very, very similar to what we talked about earlier, but the difference here is that hand action classification means that we can track our hand action across multiple frames. So if we were to do something, let's say like raising our hand, or maybe even better, let's say clapping. If someone were to clap and we had a hand action classification model, we could actually track when they are clapping versus when they are just holding their hands in the air or in front of them. So this could be really useful in a particular scenario where you'd like to identify when people are clapping. Motion. So this is going to classify the dominant activity captured in motion sensor data. Again, very similar to the other machine learning models we've talked about already, but this is particular to sensor data. So imagine something like a thermometer. If the thermometer were to go up really, really high, really fast, we could classify that activity as something that maybe we're worried about. Or if it were to go the other way, we could also classify that as something that we're worried about. So that's a very simple example. This is most often used in things like car crash detection and other things where we have, again, motion sensor data that's coming in very frequently, large amounts of data, and it's not something that we could necessarily classify on our own as humans really quickly. But using this machine learning model, we can classify that motion sensor data very, very quickly and act on it, like calling emergency services in the case of a car crash detection model. Sound classification. So this will classify the dominant sound in an audio clip. This is used on iPhones to identify when things like maybe a baby is crying in the background, or maybe if the phone is ringing. This is a great accessibility feature. And so sound classification is, again, just another thing that is taking in a lot of data and maybe more data than we can necessarily process sometimes, or maybe again for someone with certain disabilities, sound classification can be really, really helpful if they don't necessarily have the ability to hear very well. Text classification. This one is pretty useful, just like the rest of them, but definitely text is something that we all work with pretty frequently, and so it's pretty straightforward. Text classification classifies the dominant topic, theme, or sentiment in natural language text. So a great example would be, let's say, reviews of a hotel. We could identify which reviews have a positive sentiment or which reviews have a negative sentiment using a text classification machine learning model. Word tagging is the ability to split natural language text into classified phrase or word tokens based on their contextual roles. So this would be the ability to take the specific words within the text and again tag them as what's the most important. So going back to our hotel reviews example, maybe we use text classification to identify it's a negative review, but then we could use word tagging to identify why it was a negative review. So word tagging could identify words or sentences like squeaky bed, loud neighbors, maybe broken AC unit. These would be the type of things that we would like to tag, and hopefully there's not too many of those bad reviews, but definitely if there were, the combination of text classification and word tagging could really help us narrow down to exactly what was the problem, or maybe the opposite, what people really love about our product. All right, last but not least is going to be our table. So we have tabular classification here. This is essentially an Excel sheet. So a data table that has tons and tons of data. Usually it may be something historical or categorical, but here we'll read the definition. It predicts the categorical value of a feature given other features' values. Features are represented as columns in tabular data. So the best example I have here would be classifying, again, just large amounts of data. Like if we have different categories and in one of our categories we have the same number repeating over and over again, maybe that's something that we need to classify, and tabular classification could do that. Tabular regression predicts the numeric value of a feature given other features' values. Features are represented as columns in tabular data. So again, this is the ability to take an Excel sheet and identify certain patterns specifically around numbers. I would say one of the most common examples for this would be home prices. So something like real estate, where the prices go up and down depending on the year. That is something that we could use tabular regression for to hopefully predict the price of homes in a certain area at a certain time. And recommendation. This is going to recommend new items given others based on how often users interact with or rate them together. So this recommendation could be something as simple as a new recommendation in your Starbucks app. Let's say you order something like a chai latte all the time, and now based on that pattern of you ordering chai lattes, the Starbucks app is recommending their new apple crisp chai latte as an example. But recommendation, I would say, is the ultimate level of AI, because at that point, machine learning, because at that point you're taking all of the data and you're actually measuring how often some of these data points occur. And then from there, you're making recommendations for the user. So essentially it's personalized machine learning. And definitely once you've implemented the rest of the machine learning models, recommendation would be my next recommendation. Our very last model here is more so exclusive to a mobile device like an iPhone, but this is object tracking. And this is essentially the ability to track an object in a 3D space. So previously we mentioned an image or a video. These can be really great, but if you're using some sort of 3D application, then a machine learning model for tracking objects in 3D can be really helpful if you're developing for something like an iPhone or Apple Vision Pro. But these are, generally speaking, the major categories of machine learning models. So I hope this has been a very helpful explanation and breakdown of how you can actually create your own machine learning models and how you might implement them or when you might implement them. If you really want to deep dive and learn more about creating and deploying your own machine learning models, I highly recommend taking a look at Microsoft Azure AI Fundamentals, the AI Overview. This is a learning path about 3 hours long, but it includes some really great content on the fundamental AI concepts, introduction to machine learning, and the fundamental of Azure AI services. Now, Azure AI services are essentially the machine learning models that I just demonstrated on the Apple side, but these are available in the cloud, meaning you can deploy them at an enterprise level scale. And again, maybe not necessarily train them locally on your own device. You could actually train these models on the cloud instead. So definitely take a look at this Azure AI Fundamentals course if you want to take a deeper dive. And as someone who's already completed the course and actually used this content, I'll go ahead and take a look here at the Azure AI services that I currently have available. And let's just take a look at what you can do. Because again, this is all directly tied to what I just showed you, but Microsoft has fleshed this out to be very, very specific for the purpose of enterprise. So Azure OpenAI account, this is going to be for connecting to models like ChatGPT, but via Azure, so an enterprise safe version of the GPT models. Azure Search allows us to bring our AI-powered cloud search to mobile and web apps. So this is the ability to have a search engine like this one here, but within your apps, and again, searching a little bit deeper than a traditional basic search engine. Computer vision is the ability to analyze content in images and videos, similar to what we talked about earlier with our image classification models. We have a face API that is specific to detecting and identifying people and emotions in images. This can be controversial at scale, so I do want to point out that again, these are things that are available through Microsoft, but they may not necessarily be right to deploy in certain environments. Custom image or custom vision allows you to customize image recognition to fit your business. So just like we talked about earlier, if you'd like to create an image classification model, maybe identify specific areas in your business or specific processes that are going correctly or incorrectly in your manufacturing process, custom vision may be for you. Speech service is great. It offers speech to text, text to speech, translation, and even speaker recognition. So this is that feature that allows you to have transcripts in apps like Microsoft Teams that correctly identify who is speaking and when. Language service allows us to build apps with industry-leading natural language understanding capabilities, meaning that if I say something like, hey, I'm going to the grocery store around 7 p.m. tomorrow, we can actually extract the data from that and maybe even create a calendar event based on our language service. Translator translates more than 100 languages and dialects. Document intelligence allows us to turn documents into a usable data at a fraction of the time and cost. So this is going to be different than just giving your document to ChatGPT. And if anything, it may be more exhaustive, meaning it actually goes through the entire document and we can break things down in a way that's different than a large language model would break it down. Bot services are going to be old school traditional bots. So these are just basic chat bots, not something that's necessarily ChatGPT, but you could level it up to something that uses a GPT model. An anomaly detector is similar to the sensor machine learning model that we talked about earlier. So this is going to be great for identifying potential problems early on. Again, if the temperature is too high or too low, we can detect that anomaly and act right away using our machine learning model in the cloud. Content moderator detects potentially offensive or unwanted content. We have health insights to help support insights around health and just again identifying these things a little bit earlier and faster and easier than we would if we had a huge amount of health data in front of us. Our personalizer is going back to what I talked about earlier, our recommendations model. This is going to create rich, personalized experiences for each user. This would probably be the last thing I would implement because the rest of these things will support actually creating an engaging, personalized experience for our users. Metrics Advisor proactively monitors metrics and diagnoses issues. Immersive Reader is great for helping people read and comprehend text. So anyone with any type of learning disability, this can actually help them read and comprehend a little bit better when implemented correctly. If we'd like to tie multiple Azure AI services together, we can do that. Again, going back to content safety, we can always do that. And there's still the classic language understanding, which may be a little bit dated. So I wouldn't necessarily recommend any of these classic models, but they are here for your use. So this is Azure AI. These are the services that Azure AI offers, which again, this is Microsoft. So you're getting enterprise grade security, enterprise grade uptime, and overall, these models are tested and customizable, so it's not like you're just using something out of the box. More so, they've standardized the process of creating models like this so that you can create something that works for you and not necessarily have something that's just a one size fits all.